Hello and welcome to part 2 of lecture 4 in which we discuss about looping control structures. So far we understand that we might need to repeat some blocks of code in a computer program. But how many times do we need to repeat that block of code? It is possible that we don't know the exact number of repeats. At certain times we may know at the time of the writing of the program we may know the number of times we need to repeat that code block, but on the other hand sometimes we may not know that the number of repetitions may depend on some conditions, and hence the number of repetitions would only be known at the runtime. So we need to deal with both those situations. So in repetitive or repetition control structures, those situations are handled in different ways. So as we have already discussed in a previous section, one way to handle the repetitive code would be to duplicate them, to repeat the block of code over and over, which we already know that is going to be inefficient and it's not very useful. Once you have that kind of implementation, it could be quite difficult to organize your code and your program. It would be not a recommended thing to do. So that's why we are we are interested in looping control structures. So therefore, we use two major constructs supported by Python. I did mention that these two constructs are supported not just by Python but other regular programming languages as well. So the first thing is the for loop. The first repetition control structure is the for loop, and then the while loop. So we will be going through details about these two major types of repetition control structures in this section. So we are going into deeper details on the for loop first. So what the for loop does, it repeats the block of code or block of statements a specified number of times, or in other words, a definite number of times. So at the time of the writing of the program, we actually know how many times that block of code needs to be repeated. So that's the speciality of the for loop. So there's a specific format uh, that we use when we implement or when we write the for loop in a program. So there are two important keywords. Obviously, the first one is for, and then there is in. So here, after the for keyword, you have what we call an iterating variable, and then in a certain sequence. So that is the regular structure. We have the colon afterwards, and then we include whatever the statements, whatever the lines of code that needs to be repeated in the looping control structure. So notice the indentation. So when you have, so you define the for loop in this way, and in the next line you introduce the indentation. You indent the next line or the next block of code so that you include that block of code inside the for loop. So whatever that is indented, the block of statements, uh, that's the one that's repeatedly executed or repeatedly called, that block of code is called, generally referred to as the loop body or the body of the loop. The loop body has to be indented, as I have already mentioned. So that's how the Python interpreter will know that, okay, so this part has to be repeated. So this part is within the for loop that is defined. So pay attention to the keywords and pay attention to the repeating, so the iterating variable and the sequence. So now we look at a very simple example that implements a for loop in Python. So the very first line, you can see the two keywords for and in, and here the iterating variable is the variable named counter, and in place of the sequence we have a special function called range, which in this case takes in two arguments. So we will have some further information about the range function, but for now we will keep in mind that it provides a sequence of numbers. So when we provide two parameters to the range function, this means start from 1 and stop before 6. So this, in other words, this range function will give us a sequence or a list of numbers starting from 1 and ending from 5, not including 6. So that's the meaning of the first line of code. So iterate through. So this for loop tells the Python interpreter to iterate through a sequence of numbers. So in this case, how many times? 5 times, starting from 1 going up to 5, and this iterating variable will change at each of the iterations. So the next line, basically what we are asking is to print, this is a loop and the counter, so this part is the string, and then this is the value of the iterating variable. So what will be the output looking like in this example code? In the execution, it will display at the first iteration, it will say this is a loop, counter is equal to 1, because at the very first or the starting number in the sequence would be 1, because the range function which will give us such a sequence. So that will be the first line of output, and in the second iteration it will print a similar output, but this time the value of the counter is 2, because in the sequence number 2 is coming up, and we can see in the next few lines it will print counter is equal to 3, counter is equal to 4, and counter is equal to 5. After that line the program will be terminated, because the for loop has, in this case, a definite number of repetitions. We do know the number of times the for loop will repeat. How many times? In this case, it's only 5 times, because it's specified by this sequence. Numbers starting from 1, ending at 5. 5 repetitions, a sequence with 5 numbers, and the iterating variable changes accordingly. So this is how the simple for loop operates. We go back to the Python tutor to visualize the example that we just described. So it's just a program consisting of 2 lines, and which includes a for loop. So we already know we have a iterating variable called counter and a sequence going from 1 to 5. So let's move ahead and try to see what is coming up at each step of this program. So similarly to the previous demonstration, a green arrow shows the line that just executed, and the red arrow shows the next line to execute. So we are at the very start of the program. So hit next. You see that immediately the iterating variable is assigned the value 1 because the sequence is giving that. The starting sequence or the starting number of the sequence is 1. It's already assigned to the iterating variable, and hit next once more, and the print statement is executed for the first time, and it says this is a loop, count is equal to 1. Hit next. Now see, the counter is assigned the value 2. In the next step, print will be executed, and it says this is a loop, counter is equal to 2. And next iteration, counter will be 3, and it will be printed accordingly. So this will go until the maximum value or the last value of the sequence is reached. So this is the fourth print statement, and then finally the counter becomes 5, and it will print the last line. And when I hit next, it is done running. Went for 11 steps, and the sequence is done. Sequence has had 5 items, and it is now all gone through and executed, and it has printed 5 lines, and it has gone through the values from 1 to 5 through this definite for loop. Here's a fun piece that actually illustrates the usefulness of looping controls. So this is something you all must have gone through in your school days. So you do something unwanted, your teacher may have asked you to write that you don't do that many number of times, say 500 times. But this person here does that in a cleverer way. That person uses a for loop. However, you will notice that it is not written in Python. It is actually written in programming language called C programming language. But we are not actually going into the details of C, but you will see that conceptual wise it is quite similar. So there's an iterating variable, and it is using a for loop to write in how many times, 500 times, that I will not throw paper airplanes in a class. So that's a clever way of doing that. So that is a fun thing, but also demonstrate the usefulness of iteration or loops. As I have mentioned previously, we will look at the range function in a little bit more detail because it's quite useful and commonly used alongside for loops. So this is used to iterate over a sequence of numbers, or we would rather say generate a sequence of numbers. So it is a built-in function available in Python, and it generates range objects containing arithmetic progressions or sequences. So we can use it in multiple ways. It can take up to 3 arguments. So if you pass only one or if you use only one parameter, it gives you the you are actually only providing the upper bound of the sequence. By default, it will output a number sequence starting from 0. So you are providing it only the upper bound if you only pass one argument. So this, in this case, in this example, it is number 10, and it will give you a sequence starting from 0, and notice that the default step is also 1, 0, 1, 2, 3, 4, and so on up until number 9. It will not include number 10. So it is the upper bound. It is not inclusive. So that's the situation where you only use one argument. But as I said, it can take up to 3. If you use 2, you are defining a starting point. So this is the example that we saw in our previous implementation. We had starting point as 1 previously, but now we have 5, and this is once again the maximum or the stopping criteria. So it will provide us a number sequence starting from 5. So this is included, but this is not included. It stops at 9. So what's the third argument? If we have one, these two are same as before. 0 is the starting number and 10 is the upper bound and 3 is the step. I did say that by default the step is 1. So difference between any two numbers, any adjoining numbers is 1. But we can change that. We can define our own step. So in this case is 3, and if the sequence will start from 0, the second number will be 3 because our step is 3 in this situation. Third number will be 6 and fourth number will be 9, and it will not go any further because we have defined the upper bound. So that's how the range function operates and provides number sequences. And you can also have negative numbers. So in this case the starting number is -10, the lower bound in this case is -100, and the step is -30. So this sequence will include -10, the starting point, and -40 because the step is -30, and it will stop at -70 because this is the lower bound. So this is how the range function can operate and provide us with number sequences, especially useful in for loops, implementing for loops. If we look at another example, in this program we are expected to compute the sum of all even numbers up to 100. We need to decide on all the even numbers up to 100 and including 100. So let's see how we write this program. So we need to first the target is to sum all even numbers up to 100. So what we initially do is define a variable called total. So here's the variable called total, in which we would add the values, keep on adding the values of all the even numbers. So the next step, we will use a for loop. Notice the keywords for and in. This is once again the iterating variable, and we have a sequence. So sequence starting from 0, upper bound is 101, so a stopping point. So we need numbers or even numbers up to 100. Because of that, we define the stopping criteria as 101, because this will not be included. It will only go up to 101. And our step is 2. Why is that? We only need the even numbers. Start from 0, go 2 steps ahead, and you will have number 2. Go 2 more steps, you will have number 4. Like that, you will get all the even numbers up until 100. So what we do in the body of the loop, we accumulate. So this you probably have seen this operation, plus and equal sign together. What it does is, whatever that comes in on the right hand side is added to the value of the variable on the left hand side. So this is equivalent to say that total is equal to total plus counter. Okay, so every time the loop is going on, at each iteration, the value of the counter variable will be added to the variable named total. So in that way, we will get the sum of all even numbers until 100. So eventually the program will print the total value or the sum of all the even numbers until 100. Notice the indentation once again. So whatever that you need to put inside the for loop has to be indented. On the other hand, this print statement, it is not included in the for loop. It is not indented. It is not inside the for loop. It will not repetitively be called. Okay, so this is outside the for loop. Only when the for loop is done, only when the for loop is completed, this print statement will be executed. Now we will visualize this example in Python tutor. So we have the code here, total starting from the total value assigning to be 0, and we have the for loop. After the for loop is done, we expect to print the total of all the even numbers. Right, so let's quickly go through. So if I press next, now the total value is currently 0, so nothing was added to that. So we are now going to go inside the for loop. The next line is going to the definition of the for loop, and if we hit next, now the counter variable is initiated, the iteration variable is initiated, and now in the next line will be executed, that is the body of the for loop. So let's see what happens. The counter is 0, total is 0. You see that none of the total did not change because it was all zeros. 0 added to 0, it's still 0. Now go into the next part, and now you see that the counter, the iteration variable, is assigned 2. So in the next step it will be added to the total value. Now you see that total becomes 2. So this will happen until we traverse through the full sequence. What is the full sequence? The number has to go up until 100, right? So that's our expectation. We are counting all the numbers till 100. So you can see that number of steps. So we have to go through 105 steps. So we are right now at 90s. So eventually it will reach the final steps. So it has counted all the even numbers until 100. So this will be the, so now you can see the execution is at the it is out of the for loop because it has traversed the full sequence, and now it will come into the print statement and will print the total, which is, you already can see it's 2550. The counter is 100, and it will not go any further because it is the stopping criteria 101. There will be only numbers up to 100. And when I hit next, the program is done running, and the total is displayed as total is equal to 2550. Now we look at another example. So we are supposed to write a program to compute all the sum of all the integers between any given two numbers. So previously we had fixed numbers, numbers starting from 0 up to 100, but this time we are expected to get the input from the user, so to get any two numbers. So look at this example now. So we are at in the first line, we are getting input from the user, enter the first number, so that is the the first number in the range, and then second number in the range. Read carefully that in this example we are expected to get the sum of all integers between any given two numbers. So that means we are not to include any of those numbers. So the first number and the second number should not be included. They should be excluded. So we have to write the program in such a way. So in the third line, we have a sum variable which will be accumulated as we go on in the for loop. So the iteration variable in this case is capital N, and the range, notice the difference from previous example. So the starting point, now we are defining, we are reading the first number, but we are adding 1 to that, because when we get the sequence from the range function, it will include the number given here. So if we had just num1 here, it will include num1, but we are not expected to do that, because we need to get the values between these two numbers but not including them. Putting num2 as it is here should be okay, because the range function does not include the second argument. So up to that we are good. So what happens is similar to the previous occasion, sum is accumulated. So now notice that we are not using that plus equal sign. Instead of that, sum is equal to sum plus n. So both cases are similar. And finally, this is the print statement. The sum is string part, and then the value is displayed. So that's how this example is approached. So we will visualize the example in Python tutor. So we'll be getting two inputs from the user, num1 and num2, uh, in order to come up with the sequence. So we need to get the sum of all the integers between those two numbers. So we will input the numbers, the first number as 10 and the second number as 20. So you can already see that num1 is 10 and num2 is 20, and the code will now move on to initializing the sum variable and then move ahead to the for loop. So let's see what happens inside the for loop. So n is initially the first value for n, the iteration variable is 11. Why is it 11? Because num1 is 10 and we are adding 1 to num1. So initial value is 11. So we need to get all the integers between 10 and 20, not including those two numbers. So that's how n becomes 11. And now it will iterate through all the values. So n will become 12. Now the sum is 11. Next step, sum is 23. Next step, n is 13, and sum becomes 36, and so on. So this will go ahead until we reach the maximum point, which is 20. So n is 18, n is 19, and now it will go out of the loop. So here, as the last step, the print statement will be executed, and the sum is now 135. So this is the sum of all the integers between 10 and 20. So finally it will display the sum is 135. So the program is done running. So we have an idea how this program is executed and how the for loop is operating in this kind of an example. So far we have seen a number of examples. So I'm listing out a few more examples which is available on your notes. So first one is to write a program to display the integers from 100 to 200. Another one to look at can the loop body of a for loop never get executed. So you should go and try out to find an answer to that. So I'm not going to give out the answer at this stage. You can work by yourself and decide and try to answer the question. And also another a little bit more complicated exercise would be to write a program to calculate the factorial of any given positive integer. So you can take a positive integer as input and try to calculate the factorial. So the definition of the factorial is given here. It's a mathematical notation. You can attempt to write a program to calculate the factorial of any given positive integer. So please try out those examples by your own. And that concludes the part 2 of lecture 4.